Okay, last one without numbers. And again, I'm just doing this so you can kind of get the feel for how these graphs relate to the picture, the first one, and the second one, shear and moment. And this time we're doing a member on a pin and a roller, right? With just one force right there in the middle. So what do we see right off the bat? We're gonna have reactionary force here and there, right? A and B. And since this is a pin, we're also gonna have one here because it's holding it from moving this way, and it's holding it from moving that way. So we're gonna also have one there. But since there's no other forces acting in the X, we're gonna say it's 0. We can assume that. Okay, so the only reactionary forces that we have are A and B, right? And we can start by summing the forces because there's no real like, you could start with the moments, I guess, about A. Actually, you know what? Let's do that. I like doing that. Let's just get in the habit of doing that because I like to do that. Okay, so sum the moment at A equals 0 equals, let's see, negative P times, what is this, L, and that would be L over 2 because it's halfway. And then plus, right, because that's going with that sign convention, to be turning it that way, plus by, put that there, and that's times L. Okay, so then we can solve for by. So what do we got? by is, put that over there, Vp times L over 2, and then divide by L. So that would cancel out that L, and by would equal P over 2, which makes sense, right? Because there's two forces. I assume they're putting equal effort to keep this beam up if this force is in the middle. So we can assume that, or let's sum the forces in the y. Equals 0 equals AY, right? AY plus BY minus P. Those are our three forces. And BY, right, that was P over 2. So that makes AY, right, let's see, negative P over 2 minus P would be positive P over 2, right? So then what we can do is we'll start by doing the, so we have all of our forces, right? We know BY, we know AY, we know P. So let's start with that. P over 2, so our first force A equals P over 2, so that's how high we're going to jump up, right? P over 2. And then here's another reason why I like to line these up in this way, is because now you can make, like, where is this? On this line, you can make a nice dotted line. Oh, shit. Nice dotted line that goes up all the way through your force. That way you know where exactly shit's going down on the graphs. So we started at P over 2 because that was the magnitude of AY, and it was positive, so we went up. And then nothing happens to the beam until P, right? So P, it's going to be twice as big as P over 2, and it's going down. So we're going to go down to here. All right, and then keep going left to right. Nothing's happening until, boom, here. Another force, By, and it's also positive P over 2. So we're going to go up another P over 2, and it brings us right back to 0, just like we thought. Now, for the moment diagram, I'm just going to do it by looking at how this one looks. I think that's the best way to understand this concept. Right, okay, we got this area, right, would be P over 2 times L over 2, right? So, and there's nothing going on for moments at A, so it starts at 0. And we go up linearly to that value, P over 2, L over 2. And then what? Right, this was positive because this was positive. This area is positive, being above this x-axis. So this slope was positive. So now, what do we got? A negative area, right? It's under the x-axis. So this next slope is going to be negative, and nothing else happens to it. So we know it goes back to 0. And there you go. We'll get the numbers in the next one. Just wanted to hit all the most common like loading types that I've seen. So